Welcome to Academic Judges class. Today we're going to be treating permutation. I not say combination, I say permutation. So we'll do permutation. In our next class we'll treat combination. So before we treat permutation, I want us to first of all understand this word factorial, because this is like the units for permutation. Another name for this word factorial is ways, or you say position. I need you to think of it this way. So we normally say that factorial is defined as a function. We define it as a function which multiplies itself with numbers below it, or you can say before it. Below it, or you say before it. Numbers below. Example. If I say 2 factorial, we represent this with this exclamation mark. So if I say, you know that unit is the standard for expressing or representing or should I say detailing quantities. So I said that for permutation, this is like the unit used, ways. So factorial. So if I know this, if I have 2 factorial, this is the same thing as saying 2 times 1. And notice that 1 is below 2 and 1 comes before 2. If I say 3 factorial is equals to 2 times 3, it multiplies itself with numbers below it. 3 times 2 times 1. And notice that this thing is almost the same thing as saying 3 times 3 minus 1 times 3 minus 2. 3 minus 2 gives you 1. This is also the same thing as saying 3 times 3 minus 1 times 2 minus 1. I seen it. So if I have, for example, 4 factorial, this is the same thing as saying 4 times 3 times 2 times 1. This is the same thing as saying 4 times 4 minus 1 times 4 minus 2 times 4 minus 3. 4 minus 3 gives you 1. 4 minus 2 gives you 2. So if I know this, which means that if I talk about n factorial, this is the same thing as saying n into n minus 1 into n minus 2 into n minus 3 dots up to n minus r plus 1 factorial. So if I know this, I can progress to solving questions on this. Let's say we are asked to evaluate. Let's say we have asked to evaluate what we have here, 0 factorial, and we know that 0 factorial is equals to 1. Why? Because remember we said that another name for factorial is ways or position. So 0 can occur in just one way. 1 can occur in just one way, because 1 times anything is 1. Is that thing. 1 times anything is that thing. 1 raised to power anything is 1. Square root of 1 is 1. The same thing with 0. So even if I put 0 times 1, see that it will be 0. So just like when I say 3 factorial, inside 3 I have 3, 2, 1. If you count these things, this is position 1, position 2, position 3. Inside 2 I have 2, 1, position 1, position 2. Inside 4 I have 1, position 2, position 3, position 4. So the same thing for 0. 0 has just 1 position. 1, the same thing. So inside 1 I don't have 0. 1 is 1 on its own. So if I know this, that is why we say that 0 factorial is 1 and 1 factorial is 1. Now that you know this, if I ask you 1 factorial, you know it. So let's look at that question. It says find n permutation n. So if I'm to find n permutation n, let's just check what it means. We know that we've not started dealing with permutation. We've not started treating permutation. So I think we just have to stick with our scope of, let's say I am asked to, let's not go to permutation yet. Let's say I'm asked to find, we are still in factorial, 5 factorial, 6 factorial, all over 4 factorial. This should give me the same thing as saying 5 times 4 times 3 times 2 times 1. And you know that this is something as saying 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 times 5 minus 4. Once you're able to represent it to the last, to the lowest, this is now the lowest part. The last part you leave it is now what is 1, the factorial. So, and 1 factorial is 1 times, you see what I mean? If I break this 6 down to 6 times 5 times 4, and I want to stop here, I'll come and put factorial here. So the only thing having the factorial now is the 4. Are you seeing it? So, but I still want to go down. I have times 3 times 2 times 1 all over 4 times 3 times 2 times 1. And assuming I left that factorial up here, it will come and meet this factorial there, will both cancel. But see that it's the same thing now. So when they cancel, if you times this, you should get 3,600 as your answer. And I told you, the units, once you do this factorial, you can say that this will occur in so 3,600 ways. So let's say I am asked to get for example 15 factorial all over 11 factorial 4 factorial plus 15 factorial all over 12 factorial 3 factorial. You know that this is the same thing as saying 15, okay, LCM. What's the LCM here? This is the LCM. This is the same thing as saying 11 factorial, 4 factorial, 12 factorial, 3 factorial. This is what is common, the LCM. So if this enter here, it will remain 12 factorial. So it will become 12 factorial and 3 factorial, all getting to multiply 15 factorial. Now, if I carry the same thing and come here, it will become 15 factorial getting multiplied, and see that there's plus sign, plus plus 11 factorial 4 factorial. So that by the time you do this, you can just use that trick I taught you earlier in class. So just factor it out so that this becomes, I have this to become 15 into 12 times, okay, see, let's do for this one. Here I'm seeing 15. Here I'm seeing 15. What is common to the two of them? I see 12. I see 11. I bring it out. Plus. Plus. Okay. Yes, plus. I see 15. I see 4 and 3. Okay. So I can put 3 factorial here. So plus, if you don't want to do it this way, you can do it by going through all the hassle. So I now have 15 into 11 factorial into 4 times 3 factorial. So all over 12 factorial, 11 factorial, 4 factorial, 3 factorial. So notice that here what I'm doing is just trying to bring it to have the highest before the lowest. So this should give me 15 into let's check. Should give me 15 into 15 factorial into 11 factorial, then 3 factorial into 12 plus 4 all over 12 factorial into 11 factorial, 4 factorial, 3 factorial. So this should give me 15 into because this can take care of this. This can take care of this. So I have 15 into 16. That is 15 factorial into 16 all over 12 factorial times 4 factorial. So I can actually say that this is the something I'm saying. Okay, so if you look at this very well, you see that this is the something I'm saying 16 times 15 factorial all over. Okay, let's say I do this thing. Okay, 12 factorial times 4 factorial. So I can leave my answer like this, or I can go further and start splitting this so that I have 16 times 15 times 14 times 13 times 12 factorial all over 12 factorial times 4 times 3 times 2 times 1. This can take care of this, and this can take care of this to give me 7. This can take care of this to give me 5. And what else? 2 can go here to give me 1, give me 8. 2 can go here to give me 4. So if you check, I have like this into this 20. I have 20, then 20 times 7 times 13. So we should get 1820. So now let's move to the next course, or the next chapter, or the next thing we have for today, which is permutation. These are questions that we're going to solve. So I normally define permutation to my students as the selection where order matters, but using selection is a bad word. So we define it as the arrangements listing or lists the arrangement list organization. Notice I'm not talking about certain words. So organization, ordering, order matters of n objects, taking all or some r objects at a time. where n, and you know that n is the total object, so n must be greater than or equal to r. R can never be greater than n. The given object, the total object, can never be less than what you are selecting or what you are picking or what you are arranging. So another way to define permutation is simply picking of objects where order matters. The picking of objects where order matters. So in permutation, order, if order matters, you are doing permutation. Order is important. So we move to the next one, types of permutation. We have several types of permutation. We have 4 major types of permutation. Under these 4 major types, if you split it, we have up to 8 types of permutation. So the first one is permutation of n objects, taking all or some at a time. So the first one under this category is permutation of distinct objects. Distinct means distinguishable, different objects. And we represent this, for under this permutation of distinct objects, we have when we are taking, that is A, when we are taking all, or say n objects at a time. And when we are taking this all of n objects at a time, it means we use the formula n permutation n. And we also have under this permutation of distinct objects, when we are taking some objects, which is r, this time around, some r objects from n objects. So in this one we use n permutation r. Very important to note. Example under this is, if I ask you, and we know what this to mean, we know that n permutation n, I'm coming, n permutation n is the same thing as saying n factorial all over n minus r factorial. That is for A. The B part is the same thing as saying n factorial all over n minus r factorial. So this is number one type of permutation, but most students take it to generalize as the type of permutation. This is permutation for distinct objects. So when you take all the objects into consideration, you use n permutation n. And when you take, I'm supposed to put n here, and you can see that n minus n is going to give me here n factorial all over 0 factorial, and 0 is the same thing as saying 1 all over 1, which is the same thing as saying n factorial. Why this one is going to be the same thing as saying, you know that n minus r, in that case, it depends on what you are putting here. So let's take, for example, if I'm asked, in how many ways can 5 different books be arranged in order? Let's look at this. They say there are 4 different books in a shelf A, B, C, D. In how many ways can the books be arranged? So we have 4 different books A, B, C, D, and this time they want us to arrange the 4 books. 4 books n. Arrange the 4 books. That means the arrangement there is also n. So that means to arrange these 4 books, we are simply going to do 4 permutation 4, which will give us 4 factorial all over 4 minus 4 factorial, which will simply give us 4 factorial over 0. And you know that this is the same thing as saying 4 factorial over 1. And 4 factorial is the same thing as saying 4 times 3 times 2 times 1. 4 times 3, 12 times 2 equals to 24. Another way of doing this is what I call the visualizing it. When they tell you to take all the any object. Here we are given A, B, C, D books. I will simply say, to arrange this book, I will take it in such a way that I have, since the books are 4, we want to arrange the 4 books. I take it that arrow represents 4 people. 4 people. Arrow represents 4 people that are going to arrange the book. Why the book is N, the object. Now, if this first person is going to meet this book, going to arrange these books, he will have 4 options to arrange this book. He will have to arrange this book from 4 options. So I'll come and write 4 times. If the third person, because he has arranged the book out of the 4, he can choose to carry this one and put here. But when he came here, his option, the books available for him to arrange is 4. So he has arranged 1 book out of it. Let's say he touched this one. Now, when the third person is going to arrange, he has 3 options to arrange from. So take it that when order matters, is the same thing as saying he goes here. It's better to use picking. Think of it as picking. When he go here, he will pick 1 book and keep, maybe carry it and keep here. So when the second person go, he will see 3 books. He will come, carry this one, keep here. When the fourth, and because when he was coming, what we will be checking is what is available, possible options. If you are looking at it as arrangements, you will find it difficult to some extent to understand. So see it as possible ways. That's why we started with factorial. So when you bring this, it's now 4 times 3. Now, if he move this book, it's remaining 2 options. If the second person go to meet this book, the third person go to meet this book, he will see only 2 books. He will carry it and put here. He met 2 options. Now, if the last person come, he will see only 1 book. He'll come and keep it here, or maybe carry it and put here. The other person kept here. Just 1 is what he meant. When you do 4 times 3 times 2 times 1, it's still 24. Now let's say, for example, we only have we are asked to arrange, out of these 4 books, that we should arrange 2 or pick 2. Let's say they say, in how many ways can 2 students, in how many ways can 2 people, or can the book be shared among 2 persons? In how many ways can 2 persons share the book or arrange the book? It will simply be, when A, B, C, D books, if you want to give the book to 2 persons, or you want to share it amongst 2 persons, you now imagine just 2 persons to be the arrow. When the first person go here, he will have 4 options. Write that 4. When the second person go, you will have 3 options. Write that 3 options. That will be it. 4 times 3, 12. That will be the answer. Assuming you are to share these 4 books. That is, assuming you have these 4 books, and you want 2 people to pick, you want to share, to give 2 people 2 books out of the 4, or you want to arrange the books in 2 ways. This is what you go about it. We'll see a perfect question that we'll use to analyze this, but I want you to get it as, should I say, think of it as, when you go there, what do you have? When you go there, what do you have? What do you go there, what do you have? Your available option. So let's move to an example. Okay, another example. They said here, in how many ways can one arrange 3 bags of beans? 3 bags of beans. And notice that 1 person is arranging these 3 bags of beans. It is simply going to be, how many options will the person see when he come there? He will see Oloka, Potiskum, and brown beans. He will see 3 options. So when this person goes to arrange these 3 bags of beans, he will see 3 options. That means that what is available to him is 3 times 2 times 1. Very simple. So that is what he will meet. So whenever 1 person go to something, he has the option of seeing everything there. While when the second person go there, he has the option to see what the first person left. That is how you go about this permutation and this combination, thinking of it. But remember, we are still treating permutation. They say the next one, in an examination, we are given 5 questions to answer 3. How do we arrange the answers? in an examination we are given 5 questions, 5. Then yes, this is a perfect example like that second, the B type. In an examination we are given 5 questions to answer 3. How do we arrange the answers? What I will simply say is this falls under here because we are given 5 questions. Now we want to arrange 3. So 5 questions, N is 5. R to arrange the answers. And the answers they give us, we have 3 answers. R is 3. So what I will say is simply, I have question 1, question 2. Before I use this formula, you can think of it this way so that this way, this visual aspect becomes more important because it will help you answer any question. It's not every time you know that you use this formula because there are some complex questions. But if you're able to learn this visualizing, it becomes easy. So I will say I have 5 questions. I have 3 answers. That means that for the 5 questions I have, if I want to arrange my answer, let's say I don't know book and I want to arrange my answer, I can carry the answer for question 1 and put inside question 5. I can even carry it and put here or put here or put here. The option is up to me. So the first option you have is 5. And remember I told you that the word we use when we are doing this permutation is factorial. So if I put my first answer has 5 factorial options. Anytime you say, can 1 do? So if you do something once, your option is everything there. But notice that since they are talking about 3 answers, by the time the second answer is to be taken, it will now have 4 positions left. So in that case, this factorial will turn to multiplication. It will make room for what is next. So by the time you pick your second answer and put in any of this, you now have 4. Then by the time you get your third answer, let's say you've carried your answer and put here. You've taken this out. You come and put here. You've taken this out. 3 options remaining. So by the time you carry your third answer and come, see that you have 3 questions to fix in this. You put times 3. So your answer is going to simply be what you have here. Very simple. And we know that by the time you do 5 times 4 times 3, you have 60. So this is your answer, 60. So you can arrange this in 60 ways. Very simple. Now, they asked me again, they said, in how many ways can a teacher arrange in order the winners, first, second, and third among 5 final years? If he has 5 final years before him, that is question 4. If he has 5 final years before him, even these questions are very simple. They're even giving you a range. There are some that they will not put a range. You just need to know it. They say first, second, and third. He has 5 final years. Then he has to do 3 things. Give first, give second, give third. So when he comes to the final year, 5 people he will see. He can give it to any of them, but it matters who takes first. He will give to the person that took first. That is out of 5. Then by the time he gets to give for the second person, he is having 4 options. By the time he moves to give to the third person, he is having 3 options. So it's going to be 5 times 3 times 4. Very simple. In how many ways can the librarian arrange 7 books in order on a library shelf? In how many ways can the librarian arrange 7 books in order on a library shelf? Notice that is somebody, like just one, and he's to arrange 7 books. And it's not like maybe out of these 7, he's arranging it in like maybe arrow ways, like 2 ways or 3 ways. So he's having the 7 books, he's to arrange the 7 books. So he has 7 options. So this is the sentence as saying 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. That is the number of ways you can arrange this, whatever answer you have there. Now, in how many ways can 3 schools be arranged in a line for matching competition? Is 3 schools. 3 schools. There is no arrow there. There's not like there's no sum or selection or maybe picking out of that 3. You have 3 options, and these 3 options that you have, you are to arrange it. So it's the sentence as saying 3 factorial. So the number, how many ways can 3 schools be arranged in line for a matching competition, is simply going to be 3 times 2 times 1. Very simple. Now, number 7, they said, find the number of ways in which 3 students out of 10 students can be awarded first, second, and third. We have total 10 students. The bigger number is always your any 10 students. In how many ways can 3 students be arranged out of 10 students? It's simply going to be, out of that 10 students, by the time you pick your first, you have 10 options. By the time you go to pick your second option for who you give second, you have 9 options. By the time you go to give the third person, you have 8 options. So the answer to this question is going to be 10 times 9 times 8. That is your answer. Very simple. Now that you know this, let's move to the number 8. Okay, you look at number 8, you see that number 8 is not in the category of this type of permutation. So let's move to the second type of permutation. Let's move to the second type of permutation, because we are done with permutation that has to do with distinct objects. This question number 8 has to do with identical objects. So the second type of permutation you need to know is what we call permutation of identical objects. Permutation of identical objects. So that is number 2. Let me do this here. Permutation, that is the second type. Permutation of identical objects. So I told you we have up to 8 major types of permutation. So some of you know just one, and those ones you know from secondary school, they taught it somehow. Most of my videos are videos that you can even give to your siblings doing WAEC, common entrance, and the rest. It will help them, because I know how students go through a lot when it has to do with this kind of questions. They don't give them details, and details is what they need. So for the second type of permutation, when you're taking R objects, or we say it's identical when they are alike. So I normally define this in which we call it indistinguishable. If you don't call it identical, you say it's indistinguishable. So for indistinguishable type of permutation, the formula is given by, if I have n objects, and k and nk and nk, nt and nc are indistinguishable, that is, or should I say, I can say they are identical, because when you say something can be distinguished, it means they are different. So if they are indistinguishable, it means that they are alike. So all I will do is to say the n objects, the formula I will use is to say the n objects all over the number of repetition. Once I notice that the elements or values inside this n objects are the same, I will do n objects all over number of repetition factorial. So n objects factorial all over number of repetition factorial. Say for example, let's say I have Tinubu for example. In this word Tinubu, I will notice that this U and this U, they're repeated. But if I check the position, this is 1, 2, 3, 4, 5, 6. So I will simply say that to find this permutation, it will simply be the same thing as saying, to do this, I'll simply use 6, that is number of objects 6 factorial, all over the U repeated 2 times, 1 and 2, all over 2 factorial. So this is going to be the same thing as saying 6 times 5 times 4 times 3 times 2 factorial, all over 2 factorial. These two will cancel. So by the time I do 6 times 5 times 4 times 3 times 2 times 1, no, sorry, Jesus. By the time I do 6 times 5 times 4 times 3, 360 ways. You see why Tinubu is taking us round and round and round. So it's taking us round the circle. Emilokon. So 360 ways. So you see it. So another question can come. They tell you, in how many ways can the letters of mathematics be arranged? So for me to do this, all I will use is to say, I'll say, okay, let's go through it. Okay, let's just undo this one before we go to a word problem, because sometimes this all these kind of questions, they look cheap. So if I have mathematics, what I will say is, how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I will now say that number of objects is simply 11 factorial all over. Which one repeated twice? A repeated twice, 1, 2. Sometimes it can be more than 2. If it's more than 2, let's say you repeat 3 times, it becomes 3 factorial. If you repeat 4 times, it becomes 4 factorial. So 2 factorial. What else repeated twice? T, twice, 2 factorial. H, okay, E, no, A, okay. So it looks as if mathematics is only 2 times. So mathematics repeated just 2 times. Am I correct? What's missing? Wait. So I have A 2 times. I have T 2 times. I have M 2. Ah, God, I thought I've counted M. 2 factorial. So old age. So this is going to now be the sentence saying 11 times, 10 times, 9 times, 8 times, 7 times, 6 times, 4 times, 3 times, 2 factorial. All over 2 factorial, 2 factorial, 2 factorial. This will take care of this. And I know that this is the sentence saying 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 old age. All over 2 times 1 times 2 times 1. 2 can take care of this to give me 2. 2 into this again, it will get out. So I will now have my total answer to be 4,000. I think 4,000. 4,989,600 ways. Oh Lord. So that is for permutation of identical objects. So let's take a perfect example, or should I say so please, this is your own assignments. These are assignments you're solving for me. In how many ways can the letters of the word, using how I've taught you now, vacuum, Tinubu, Buhari, committee, students, Mississippi, January, mathematics, shallow, minimum, activities, maximum, commission, Bayelsa, etc. be arranged? Oh yeah, that's your assignment. The 9th question, I will go back to this. Let's just check this 9th question if it looks the same, or if it's the same question. In how many ways can a school principal choose 3 prefects out of 12 prefects to represent the school at a leadership summit? Permutation is very simple. See now, this one is like that first type. So it's the same thing as saying 12 permutation 3, or you say he's choosing 3 people, 3 prefects out of 12 prefects. When he go for the first prefect, he has 12 options. When you go for the second one, he has 11 options. When you go for the last one, the third one, he has 3 options. So 12. When you go for the last one, the third prefect, because he wants to choose 3 out of 12. So when he goes there, he has gone through when his option was his available choices were 12, 11. So he will now have 10. So this is going to simply be 12 times 11 times 10. That's the answer. Or you do 12 as any permutation. R there is 3. So let's check. Let's check for a question that looks like this second type. That's what I'm checking for. Alright, they said, question 14, they said, how many distinguishable signals? I want you to learn this and learn it well. How many distinguishable signals, question 14, can be formed with 8 flags in line if 2 flags are black, 3 are orange, and the remainders are green? Okay, so now they say how many distinguishable signals can be formed with 8 flags in a line if 2 flags are black, 3 are orange, and the remainders are green. I want you to know that whenever you are treating a question and you see formed, when I went to this word problem, assuming they did not say formed, let's say they said arranged. When you see formed, know that it's talking about combination. When you see grouped, know that it's talking about combination. When a question is given to you, they tell you how can the vice president be made, president be made, so chairman be made. In that kind of question, order matters. That type of question is permutation. But if they tell you they want to make the election and select from people whatever, there's no order there, you know it's combination. Now look at this question. They said formed. So we've now started treating combination. So I'm going to use arranged. When we get to combination, our video for combination, we will still come back and use formed so that you see how we do this question when it's combination. So let's read this again as how many distinguishable signals can be arranged with 8 flags in a line if 2 flags are black, 3 are orange, and the remainders are green. So what I will simply do here is to say they want to form signal, and the signal to be formed is from 8 flags. N is equals to 8. Now notice that my first arrow, the first arrow, R1 there, that is inside this N. Arrow is always inside N, always less than or equal to N. So arrow, the first one is 2 flags, 2, and the 2 flags are black. Then another one, another arrow 2, the repetitions, you see that is 3, and that 3, the 3 flags is orange. The remainder, so you see that 8, something that is 8, if you select 2 and 5, what is remaining is 3. So the remainder, arrow 3 is 3, and they say that the remainder is green in color. So this is it. So what I will simply do is to say, if this is like I have a flag, 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 I have a flag. Question 14. 1, 2, 3, 4, 5, 6, 7, 8. I have a flag. Now they say we want to make a signal, and they're asking me how it can be made. How many distinguishable signals can be arranged with this? So I'll have 2 that are black, the same thing. If I count this 1, 2, count this 1, 2, it's the same thing I'm counting. In as much as, even if I carry it and put here, it's still the same thing I'm seeing. So I have 3 that is orange. So see, 1, 2, 3, 4, 5, 6, 7, 8. This one is not among. So I have 3 green. So black, orange, green. So what I will simply do here is to say in this case I'll count it, is n using our second formula. Once you notice that it's identical, n is 8 all over repetition 2 times for this 2. This one is 2 factorial. This one 3 factorial. Then the remainder 3 factorial. So I'll simply do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I don't like putting that. Anything times 1 is that. So 2 times 1 times 3 times 2 times 1 times 3 times 2 times 1. This will take care of this. This will take care of this. This will go here and give you 2. So what you have is actually 8 times 7 times 5 times 2, 560. So 560 ways. Always put ways. So how many distinguishable signals? So we can get 560 signals. So 560 is ways, or since it's normally used to be ways, but here they did not ask us in how many ways, they ask signals. So signals. Very simple. All right, let's move to the next type of permutation. So the next type of permutation is circular permutation, or you say permutation of objects in a circle. Permutation of objects in a circle. So for permutation of objects in a circle, if I have permutation, that is number 3, third type, permutation of objects in a circle, or you say circular permutation, objects in a circle, or you say circular permutation. Circular permutation. So we'll come back to the questions. We use these questions when we've treated, then we'll come back to look at the question. So permutation of objects in a circle, or you say circular permutation. Now let's see. If I have this to be the tin tomato, that kind of tin tomato, you notice that by the time you do foiling, it will go round and cover it. But if you make it straight before you fold it, or anything that is foldable, it will be straight. So all these conditions we've been doing before now, the types we've been doing, is when it's straight, or maybe there is no going around. But when it's circular permutation we are dealing with, we take it that there is a center. So whatever we are given, or any object we are given, let's say we are given 7 n objects. If it's going around a circle, we take it that there is a center from there's a part of this object. One of the objects is the center. To indicate every circle must have a center. If you remember the definition of circular motion, the motion of a body around a let me not use circle, around a curved path. So if I know that, and we always say that a motion of a body where the force acts towards the center, that kind of thing. So once we are given, let's say for example 7, we take it that what we have, one person or one object is already inside the center, then remaining 6, and that one object can exist in one way, or should I say can be arranged in one way. So we say 1 factorial, then 6 factorial. So it's 1 plus 6 is 7, but this time is 1 times 6, and anything times 6 is 6, so anything times that thing is this. So it's the same thing as saying for circular permutation is always the same thing as saying 1 factorial n factorial. Or better still, better done this way, 1 factorial n minus 1 factorial, because remember that the one you have here, so if they ask me how many ways can 3 girls be arranged round a circle, or in how many ways can 3 girls be seated around a round dining table, or around a dining table, it is simply going to be 1 factorial all into the 3 gets 3 minus 1, which is going to be 1 factorial, 2 factorial. Very simple. Very simple. So which is going to give me 1 factorial, 2 times 1 is 2. 2 times, so it's going to give me just 2 ways. Very simple. 2 ways. Very simple. And if you notice it, when you have 3 people, if you have 3 people now, like this, and I want to be arranging them, if I carry this person, come here, carry this person, go here, carry this person, come here, carry this person, come here, carry this person, go here. So you see that it's almost as if, in as much as they are moving, as much as they are moving, but it's almost as if it's just flowing from this end to this end to this end. And if you check it, if you go by this, it's looking as if you are still doing when it's straight line. So we take it that it maintains a center, that is this center point, that this center point is what we use in functioning. So the best idea you get for it is that the formula for circular permutation is simply n minus 1, then the factorial. So if I know this, let's take an example for that. Let's say they ask me, in how many ways can 7 girls, how many ways can 7 girls be arranged round an object that can be turned over? In how many ways can 7 girls be arranged round an object that can be turned over? An object that can be turned over, example is the ring. When you hear a question and they give you a question, it's talking about a ring. Anything that you know that is a circle, but you know that it can be turned over. What we use in this case is simply n minus 1 all over 2. Very important. So if they ask me, let's take an example here. Let's say they ask me, in how many ways can 5 couples be seated on a round bench? So I don't want to use just bench. Let's say they put this thing round bench. So let's use round so that you understand this. On a round bench. In how many ways can 5 couples be seated on a round bench if a particular couple must sit together? That must sit together. We will not put it because we'll still get to that. That's a conditional permutation. We'll still get to it. So in how many ways can 5 couples be seated on a round bench? So it's simply going to be these 5 couples. We will simply say round bench. 5 couples on a round bench. So example, in how many ways can 5 couples be seated on a round bench? First of all, 5 couples means we have husband, we have wife. Husband, we have wife. Husband, wife. Husband, wife. Husband, wife. How many people? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is what gives you a couple. So you simply say this is 10 couples. So what you just do is 10 people instead of 10 couples. So what you just do is to apply, since it's round bench, one person goes to the center, you now do 1 factorial, then 10 minus 1, which is going to give you 1 factorial, 9 factorial. So it's simply going to give you 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 ways. So by the time you punch this, that's your answer. So let's move to the next type of permutation, and that one is what we call conditional permutation. So number 4, conditional permutation. Conditional permutation. A conditional permutation is a permutation that comes with restriction, or a type of permutation where they are asking you to do something if statement comes into it. So it is a type of permutation where you have restriction, you have if, and most of each question always come with being together, when it's together, and when it's apart. So that's one thing about conditional statement. They can tell you in how many ways can something happen if this thing must be like this, if this one must come last. They can tell you in how many ways can the letters of the word family be arranged if M. Okay, let me write the question. Let me check if I have it here. In how many ways can the letters of the word family be arranged? See this question. How many letter arrangements of the word family are there if it must start with a M? Notice that if has entered it. How many letter arrangements of the word are there if it must start with a M? That is with M. Okay, with M. Full stop. So now let's say I add to it B. So we'll check when it starts with M, and if L Y must be together, and C, if they must be apart, if LY are apart. So let's try to solve this question. So for M to be the first, see, this is FAMILI. Now notice that they say they want M here, that I should get the arrangement when M here becomes the first. Notice that if M here becomes the first, that means that I am arranging three things, because I did not touch ILY. But if I'm coming here to pick up M to arrange, if I carry M and come here, it's no longer fam, it's now mfa. So for that reason, I've arranged three things. So this is the same thing as the first type of permutation, when it's distinguishable. And see that if you start doing so permutation, this one, there will be problem. What I just need to do is, so I don't confuse myself, I can say I'm taking R three things out of 1, 2, 3, 4, 5, 6, out of 6 things. So I'm taking 1, 2, 3, 4, 5, 6, 6 objects. 6 objects. Now it's 3 things I am taking. So another way you can do it is when you come here to arrange M, you will definitely see that you have 6 things. You now carry M and it's in the place of 3 and put here, which means that you've touched 3 things, which means that in this case you've touched this part where you have 6 things times where you have 5 things times where you have 4 things. So what you're going to have is simply 6 times 5 times 4. Very simple. That's the first part. So to get this M to be at the first place, you will now have this to become MFAILY. Notice that everything here changed. So this is the sentence saying, I came, met the third thing. When I met it, as I entered here, out of 6, I met it, is 6. Now, as it moves around to rearrange the other ones, this one now is 5. And this one now is 5. And this one now is now 4. So I have 5 times 4 times 6. So that is what I'll have as my permutation. That's the answer. So 5 times 4. By the time you do 5 times 4, you times it with 20. That's the how many letters of the are there if it must start with. So it will now be the sentence saying 5 times 4 times 6. So you get 120. So 120 ways, or 120 ways of arrangement. Yes, 120 ways of arrangement. That's what you have. So now see, this thing is something that if you start doing, let me carry this one and put here. Check when I will carry this one. It's something that if you start doing it that way, your head cannot carry it. So always just get used to this pattern. When you get used to it, you see that everything starts flowing. All right, let's say they now asked us if LY must be together. If LY must be together. Now let's first check something. For LY to be together, for LY to be together, I'll first of all ask myself, let's spell family. Let's F A M I L Y. They want it to be together. Let's say that L is carrying Y. Sit on my laps. Is carrying Y. So see that I now have 1, 2, 3, 4, 5. Is it not true? But notice that L and Y, they are different letters of the alphabet. So which means that L and Y on their own can also occur in two ways. So I will now say everything here, as I've arranged them to be together, it gave me 5 factorial. But the things I arranged together can occur in two ways. So it's simply 5 factorial times 2 factorial, which is the same thing as saying 5 times 4 times 3 times 2 times 1 times 2 times 1. So by the time you get the answer, this is the arrangement when they must be together. So you now have 5 times 4 times 3 times 2 times 2. So 240 ways. Now, if I want them to be apart, when I want them to be apart, what I just need to do is to use this formula. And please, before I go to that, I need you to notice that what I've done here has a formula. If you don't want to use this one, you can simply use n minus r plus 1. Then r factorial. Let's check. The n here, family, has how many words? Normally, 1, 2, 3, 4, 5, 6. It has 6 words. Minus the arrow here. The arrow here is going to be the things they are telling me to put together. Ly is 2 things. 2 plus 1. Then the arrow Ly, so 2 factorial. And this is going to give me 6 minus 2 is 4 plus 1, 5. And it's going to carry factorial, then 2 factorial. By the time you do it, by the time you do this, you get the same thing you have here. Now see, if I'm asked to get when they are apart, so the condition when they are apart, this is for when they are together. Whenever they ask me if they are apart, what you just need to do is to get the total n objects minus it from when they are together. So when you get the total n objects, that is total n objects factorial minus when they are together factorial. That's how you go about it. So to find the condition when they are apart, simply do total n object factorial all over when they are together factorial. Now this is the sentence I'm saying, family is 6 factorial. Family is 6 factorial. That is FAMILY 6 things, 6 factorial, minus total n objects minus when they are together, minus 5 factorial 2 factorial. So what I'll simply do is the sentence I'm saying 6 times 5 times 4 times 3 times 2 minus this one. 5 factorial 2 factorial gave me 2/4. So let's punch this other one. So I have 6 times 5 times 4 times 3 times 2. I have 720 minus 240. This should give me, okay, let's do 720 minus 240. This should give me 480 ways that they must be apart. So if they want me to carry the letter of the word Ly, that is, instead of having it family Ly, now they want me to maybe carry Ly, put L, put here, carry Y, come here. All those kind of running around, breaking your head, you don't need it. Remember how I'm putting this to you, because this comes from wealth of knowledge. The fact that I've tried this so many times, read so many books, and come to a conclusion that you need to know. So total n object minus when they are together. So what it means when they are apart is simply, let's say instead of I come here. Next, when I put y here, when I come, I put. Imagine you doing all these things. You will run mad. So stick to this. So another way to this kind of question is, let's say I'm giving something like this. When they are identical, let's say I'm asked to get a conditional permutation for the word well. Let's say they tell me how many letters of the word well can be, in how many ways can the letter of the word well be arranged. It can be arranged in 1, 2, 3, 4. 4. But notice that these two, they occur twice, all over 2 factorial. So 4 factorial over 2 factorial. This is the same thing as saying 4 times 3 times 2 factorial, all over 2 factorial. This is 12 ways I can arrange this. Now let's say they ask me how many ways can I arrange it so that the L and L are together. This will be the same thing as saying W, E, L, they are together. L is carrying L. So for it to be together, because they are the same words, notice that here I divided by 2 because this occurred twice. Because they are the same word, I will no longer do R factorial. When they are inside this conditional permutation, we have when they are distinct and when they are identical. So if they are distinct objects, you will use n minus r plus 1 factorial r factorial. But if they are identical, that means you don't need to do that division that you used to do that time. But what you just do now is simply n minus r plus 1 factorial. You leave it there. So n minus r plus 1 factorial. That's just what you do. And when you do this thing, okay, let's do it for this one. This is going to be the same thing as saying now, to make them be together because they are identical. Instead of doing this now, I'll just use this formula. When they are identical, this element, I'll simply do 3. 3 factorial. I will no longer have, then they can occur in 2 ways, because if you check it, this is the same thing as saying 4 minus 1. That is r now. 4 minus r. If I'm minusing the r, 4. This is 4. 1, 2 minus 2 plus 1, which will give me 4 minus 2 is 2 plus 1, 3 factorial. So when under this conditional permutation, you have when you are dealing with distinct objects and when you are dealing with identical objects. So notice that for the fact that the L and L together, I just leave it here. Now let's say, for example, a word like examination. Let's say they give me this word examination. And they want me inside this examination to make the O and N, this O and N, such that they are together. If I'm making O and N together, first of all, I'll count the number of objects here. And notice that this thing has identical objects inside it. A and A is inside it. Shebi, I and I. So I'm seeing I here. I'm seeing I. Something of 2 factorial must occur here. Then I'm seeing A. 2 factorial must occur here. Then let's check again. Is there any other thing? I'm seeing N. 2 factorial will occur again. I'm coming now. 2 factorial will occur again. Now I'm seeing what again? Okay. So normally, if I'm to find the number of arrangements I'll have here, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I should have 11 factorial over 2 factorial, 2 factorial, 2 factorial. This is the normal arrangement. But this time around, they want it to such that O and N are together, which means that instead of 11, when I count this to be 1, notice that I now have, okay, let's rewrite it. E, X, A, M, I, N, A, get out, should stay, T, I, O, N. Now notice, let's do this together then. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we now have 10 factorial. That is, we are trying to get when they are together. So remember that we must do that our conditional method, where we do, if we don't use this method, we can do 11 minus 1 plus 1. So Shebi, yes. Okay, 11 minus 2, sorry, because it's two things. 11 minus 2 plus 1 factorial. So 11 minus 2 plus 1. Anytime they are identical, they have identical, don't think of using this one. This is for when it's distant. If it has something identical, then so it's to now be 11 minus 2 is going to give me 9 plus 1. It gives me 10 factorial. So I have 10 factorial. Now I'll ask myself, inside this 10 factorial, notice that A occurred twice, I occurred twice, N occurred twice. But yes, N occurred twice. So for that reason, I'm simply going to have all over the 2 for A factorial, the 2 for N, the 2 for N factorial, and the 2 for I factorial. See it? Are you seeing it? Now let's ask ourselves, this O and N, they are not the same thing. This O and N, they are not the same thing, Shebi, which means that on their own they can actually be arranged in two ways. So times 2 factorial. Very simple. So times 2 factorial. So whatever you get from doing this is your answer. This is your final answer. This is your final answer. So, but let's say I am giving this question. Let's say I'm giving this question. Let's say I'm giving this same question. And this same question, I'm now asked to make the 2n no longer O and N. They want me to make the 2A here to be together. So let's write this. It will now be E, X, A. They want my 2 A's. They say, in how many ways can the letters of the word examination be arranged so that these 2 A's are together? So it will now be, let me just bring the A here. So let's see. This is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this kind of case, so I do 10 factorial. Always use division. The formula is good though, but it's when you've learned this division so much that you know the division method. And this division method is like my own way of calling it. When you visualize, you're able to visualize it first. So I've got it A together all over. Then I will now ask myself, this thing is the same thing as saying A now I'm carrying A, just one A. So we will no longer consider this as identical objects when we are counting the ones that occurred twice, because we've put them together. It's not the same thing as saying we just have one A. So the ones that occurred twice are not just this one and this one. So 2 factorial, 2 factorial. So we'll do it 2 factorial, 2 factorial. So notice that anytime, the reason why we are doing dividing by 2 factorial is to, should I say, cancel out the fact that these two occurred twice. So for that reason, if we are cancelling out that it occurred twice, and here now they say that this one occurred once, that is that they are together. And this, even if they occur twice inside something, we always cancel out to show that it's existing in 2 places there. So that is in the arrangements, to show that when we arrange this. So since they're already one time, these two can occur in one place. They can occur in one place, because even if I carry this A come here, carry A and come here, it's the same thing. So I don't need to come and say times 2 factorial again, or say times the number of times it can occur. It can occur once. A occurs once. If we have 100 A, A is A, yes, but it's just that each place in that place, it's, or should I say, it's occupying so many positions, which means if we still come, we always come and cancel it out in division to show that, yes, this one occurs so times. So this is going to be how I will do this. So this is my answer. So what I'm trying to create here is not just to solve question, but if you notice, with every illustration comes with an aspect of idea that you need to pick up. And when you work with it, try to put it in so many questions, you see things opening up to you. You see your understanding widening. So I believe this video is helpful, and I want you to put it into good use. So in our next class, we'll be dealing with combination. So before we round up today, let's look for questions on this. Let's see some questions. Okay, they say, in how many ways can 10 women sit around a table? So we just do 10 minus 1, which is equals to 9 factorial. In how many ways can they sit so that 3 particular women sit together? We just do n minus r plus 1 and then r factorial. So which is the sentence saying, for them to sit together, remember that our n here is now 9 for when it's round table. This is it. So it's now the sentence saying 9 minus 3 plus 1 factorial 3 factorial. So it's going to be 9 minus 3 is like 9, 8, 7 is 6 plus 1 7 factorial, then 3 factorial. This is the answer. So when you solve it, you get the answer. Now they ask us again, in how many ways may the letters of the word case be arranged so that the letter A is the last letter? This is the last question I'll take for today. In how many ways may the letters of the word case be arranged? Let me write it. In how many ways may the letters of the word case be arranged so that A is the last letter? How can I arrange this word so that A now, it now becomes C S E A? You see, in how many ways can I do this? In how many ways can I do this? And they are talking about arrangement, state permutation. Whenever order matters, or they say arrangement, or they say listing, or outline, or they are calling out something particularly, they are saying there is a position available for so chairman, vice chairman, this one, all this. No, it's talking about permutation. So case CSEA. So how do I arrange it? All I need to do is to say this is the fourth letter in this case. They want when, in how many ways when I can put it in fourth letter. So what I will do here is, in this kind of case, notice that it's now the sentence saying any object, the number of objects is 4. And the arrow object they are giving me here is 4. They want me to make this so that A becomes the last object. So it's more like telling me to go through the 4 objects. So arrow is equals to 4. N is equals to 4. The formula I use for anytime they are telling me a question, or they are asking me a question where there is a condition for me to make something to take another position. So we are moving a particular thing to occupy a particular position, to occupy a different position. I will simply employ the formula of m minus 1 permutation r minus 1. So this is going to give me 4 minus 1 permutation 4 minus 1. So which is the sentence saying 3 permutation 3. This is the answer you use. And 3 permutation 3 is the sentence saying 3 factorial all over 3 minus 3 factorial. So there's one last question I want to answer. They normally ask it. They say, where is that question? In how many ways can a traveler move from Uturu to Lagos with different... Hi, God, I can't find that question. Okay. Let's say I'm asked a couple of 8 persons consists of 5 men and 3 women. How many okay, these are combination questions, and we've not gotten to combination. In how many ways can the letters of the word for be arranged, taking all letters at a time? For, F-O-U-R, there are different letters of the alphabet, and they are taking all of them at once. So it's going to be arranged in 4 factorial ways, or you say 4 permutation 4. That's the answer. So if I'm asked a question like this, if it takes a student, that is, there are 10 airlines. It takes a student's route, that is, a student's route A to B, and this route A to B is like from Uturu to Lagos and Lagos to Uturu. So a question can come, they ask you, if there are 10 airlines operating from Uturu to Lagos and Lagos to Uturu, and if there are 10 airlines operating from Uturu to Lagos and Lagos to Uturu, in how many ways can a student go and return back? In how many ways can a student travel and come back to Uturu? In how many ways can a student travel from Uturu to Lagos and return back from Lagos to Uturu? Question like that. If there are 10 airlines, operating from Uturu to Lagos and Lagos to Uturu, in how many ways can a student travel and come back? B, in how many ways can a student travel and come back with a different airline, or different airline? The first answer, the first one is, if the student, remember I've told you, anytime you are to choose something, and when we are talking about this, it has to do with order. Notice that the student, there's an order to this arrangement. The student is moving from Uturu to Lagos and coming from Lagos to Uturu. Then they are now asking us, in how many ways can he come back? Now, when he's traveling, let's say this is airline A, airline B, airline C, D, E, F, G, H, I. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's say he has these airlines to travel with. If, let's say this is the student, as he comes here to travel, you see 10 options. You see 10 options, 10 airlines. So he has 10 options, 10 factorial. And this 10 option means the objects, number of objects or number of any for him is 10. And for him to choose is still 10. So applying permutation law is going to be 10 permutation 10. This falls under when you have all objects to choose from. So the first one, option, that is our distinct permutation. So 10 permutation 10, or that is for his going. Going is 10 permutation 10. In going, he has 10 factorial options. Now, on coming back, when he's coming back, on coming back, this is him, Simbi. On coming back, she still has, let's use she now. She still has, let's use the person to be she. She still has 10 options. So on coming back, she has 10 factorial options. So when you put it together, it's the same thing as saying 10 permutation 10 times 10 permutation 10. That is your answer. But a situation where these students now, let's say we have again A, B, C, D, E, F, G, H, I, J. A situation where this student on traveling, this student has 10 options, which is 10 permutation 10. I've taught you how to do permutation. 10 permutation 10. While on coming back, let's say coming back A, B, C, D, E, F, G, H, I, J. On coming back, this student is to return with a different airline. So let's say that the airline that took this student is airline A. So when this student comes and sees airline A, there's already that particular option that she or he should come back with a different airline. So airline A should not be among the options. So this student has just 9 options on coming back. So this is going to be the sentence saying 9 permutation 9 on coming back. So when you do it, this is going to be the sentence saying when the question asks you in how many ways can a student travel and come back with a different airline, it's going to be the sentence saying 10 permutation 10 times 9 permutation 9. Very simple. All right, please remember to like, share and subscribe to this video, to this channel. And I believe the combination video will come after this, because I took time in treating this permutation, because permutation is always more. Even the answers you have, if you have 10 as your answer for permutation, that means you should have like 5 or less. The answer for combination is always lesser, because order does not matter in combination, but in permutation it matters a lot. Say for example, I have A, B, I have B, A. In permutation, these things are 2 different arrangements, 2 permutations. But in combination, everything here means 1. You combined it, chicken. The order does not matter. Thank you.